In question number 30, consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. It reaches the ground with a speed of 50 meter per second. Take G as constant having value 10 meter per second square. Then it says work done by gravitational force and resistive force of air. So, if raindrops falls from the large height, then mgh, work done by gravity, and plus work done by the resistive force together should be equal to change in kinetic energy. That is half mv square minus 0. Here we are using work energy theorem. See, 1 kilometer height in comparison to radius of earth is very small, so we can take g to be constant, and which is also mentioned here. So, from this case, mgh, mass is 1 gram, that is 10 raised to power minus 3 kg, g is 10 and height is 10 raised to power 3. So, the raindrop which falls downward, that is displacement is in the direction of force, so the work done by gravity is positive, plus work done by the resistive force, and kinetic energy half, mass is 10 raised to power minus 3 and v square. So they hit the ground with a speed 50, so 50 square. So the work done by gravity we obtain here as 10 joule, and since it is mentioned in only one of the options, so fourth option is correct, and from this when we will subtract the kinetic energy we will obtain omega r, which will turn out as negative because resistive force will do negative work, which should come as minus 8.75 joule. A Carnot engine having efficiency of 1 by 10 as heat engine is used as a refrigerator. So, in a Carnot engine, efficiency is given by 1 minus T2 by T1. So, the efficiency which is given as 1 by 10 is 1 minus T2 by T1. So, from here T2 by T1 will be equal to 9 by 10. Now, in case of refrigerator, the coefficient of performance is heat rejected by work done, which in case of Carnot refrigerator is T2 divided by T1 minus T2, where T2 is the lower temperature. So, Q2 by work done, the work done here is 10 joule, is T2. So, bring this T2 in denominator, we will have 1 divided by T1 by T2 minus 1. So, Q2 by 10 is 1 by T2 by T1 is 9 by 10. So, T1 by T2 will be 10 by 9 minus 1, or Q2 by 10 is 9 divided by 1, or Q2 is 90 joule. In question number 32, it says an arrangement of 3 parallel straight wires. So these are the parallel straight wires placed perpendicular to plane of paper carrying current I along same direction. They carry current I outwards, that is in same direction. Magnitude of force per unit length on the middle wire B is given by. So this wire will attract this wire this side and this will attract it this side. Let the force per unit length be F, then this will also exert force per unit length as F. So their resultant will be F root 2. The force per unit length is given by mu naught I square by 2 pi d. Multiply it with root 2, or the net force will be mu naught I square by 2 pi d and root 2. So what we have here is mu naught I square by root 2 pi d. Fourth option as correct. In question number 33, it says the x and y coordinates of the particle at any time is given by x equals to 5t minus 2t square and y as 410t. Then the acceleration. So the velocity in x direction will be 5 minus 4t, and therefore acceleration in x direction will be minus 4. The velocity in y direction will be 410 and acceleration will be 0. Hence, net acceleration is the only acceleration along x-axis and is minus 4 meter per second square. In question number 34, it says the ratio of resolving power of an optical microscope for two wavelengths 4000 and 6000. Resolving power is inversely proportional to 1 by lambda, because from the diffraction pattern we see that the diffraction pattern has central maxima of width 2d lambda by d. Wider will be the diffraction pattern, then lesser will be the resolving power. So resolving power is inversely proportional to lambda. So clearly the ratio of resolving power 1 by resolving power 2 is lambda 2 by lambda 1, that is 6000 angstrom by 4000 angstrom. So the ratio is 3 by 2. So the third option is correct option. In question number 35, it reads, Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in time t1. So let the distance moved by escalator on the escalator be x. So x is equal to, let speed be v1 and time be t1. Now it says on the other day, if this remain stationary on the moving escalator, the escalator x are up in time t2. So again the distance travelled is same. Let the speed of escalator be v2 and now the time taken will be t2. It says the time taken by her to walk up on the moving escalator will be on the moving escalator. So on the moving escalator also she has to travel x, but this time the total speed will be sum of the two speeds. v1 is her own effort and v2 is escalator's effort. Let the time taken be t. So t is equal to x by v1 plus v2. Now t will be equal to x by v1 is x by t1 and v2 is x by t2. So cancelling out x, we have t1 t2 divided by t1 plus t2. Hence we have answer t1 t2 by t1 plus t2. In question number 36, it says a spherical black body with a radius of 12 cm radiates so much energy per second, because it is power at this temperature. So here we are using Stephen's law, which is E sigma area and temperature power 4. If the radius were halved and temperature doubled, the power radiated will be. So E and sigma will remain same. Although E for the black body is 1, it will remain always 1. Now, this is proportional to area depends on radius square and temperature power flow. So, as the radius is halved, so half square, and temperature doubled. So, temperature doubled, that means twice power 4. So, this will be equal to 2 square, which is equal to 4. So, the power will increase 4 times. So, 4 times of 450, which is 1800. Question number 37. It says a potentiometer is an accurate and versatile device to make electrical measurement of EMF because the method involves. So remember the merit of potentiometer over conventional voltmeter and ammeter. Conventional voltmeter and ammeters draws current from the circuit. They draw current from the circuit. They do not have their own cell. But a potentiometer has its own cell. So whatever EMF we have to measure, we measure it using null point. That is a state in which it draws no current from the cell because it has own cell. Now looking at the options, it says why it is more accurate, because it draws current from its own cell and it does not draws current from the circuit, like in case of voltmeter which draws from circuit, so the current flowing through the circuit will get reduced. Keeping this thing in mind, we have to analyze options. So it says, first says cells. Let us look at other options. Potential gradient. No, potential gradient is not the necessity. A condition of no current flows through the galvanometer. So this third option looks correct because the galvanometer which is put in the circuit of potentiometer, the null point is obtained when there is no current through galvanometer. So the third option is the correct option because it explains the scenario that a potentiometer draws no current from the circuit whose voltage it is measuring, whereas a voltmeter draws current from the circuit whose voltage it is measuring. Hence, the condition of no current makes potentiometer more accurate. In this circuit, they have asked to identify the correct logic gate. So we know this is a NOR or placed with a NOT. And now here the legs of the NOR are merged, so this becomes a NOT gate. When the legs of NOR gate or NAND gate are merged together, it becomes a NOT, and this obviously is a NOT. So NOT 2 times gets cancelled, so we are left with a NOR gate. In question number 39, it says a common emitter transistor amplifier, the audio signal voltage across the collector is 3 volt. That is output, because output is across the collector is of 3 volt. The resistance of collector is 3 kilo ohm. The current gain is 100. So beta is 100. And base resistance is 2 kilo ohm. Then the voltage and power gain. So now the voltage gain is output voltage by input voltage. V0 by Vi is IC into RC by IB into RB. Output voltage by input voltage. IC by IB is current gain, which is 100. RC is 3 kilo ohm upon RB is 2 kilo ohm. So this is equal to 150. Only one of the options has voltage gain as 150. So third option is correct. In question number 40, two disks of same moment of inertia rotating about their regular axis, passing through center and perpendicular to plane of disk with angular velocities omega and omega 2. So when they are brought in contact, finally they will rotate with a common omega. So this case is similar to a collision between two balls. And in such cases, we can use a case similar to reduced mass, or in such cases, loss of energy can be written as half I1 I2 by I1 plus I2 into omega relative whole square. The reduced mass concept videos can be seen on this channel to understand these cases. So substituting here the values, loss of energy is half, since both the moment of inertias are same, so I square by 2I, and relative angular velocity is omega 1 minus omega 2. So omega 1 minus omega 2 squared. So what we have here is 1 by 4 omega 1 minus omega 2 whole square. So second option is correct. In large number of cases which have been frequently asked in AIPMT or NEET examinations, we can use this concept of reduced mass, which is primarily used for collision but can be extended for finding loss of energy in case of disks, in case of combination of capacitors, in case of inductors, and so on. In question number 41, it says Young's double slit experiment is first performed in air and then in a medium. So in air, the fringe width beta is given by d lambda naught by d. In medium, the fringe width will be d, the wavelength in the medium, which will be lambda naught by mu. The wavelength decreases in a medium, so the fringe width will get reduced. Now what it says, it is found that 8th bright fringe in the medium lies where 5th dark fringe lies in air. Then the refractive index of the medium is nearly. So one thing about counting of the fringes is that the first dark appears before the first bright. So what we have to see here is that the 8th bright fringe in the medium. So 8th bright fringe will appear at 8 beta dash, because central is a bright, then first, second, third, fourth and 8th. Whereas this is the 5th dark. So 5th dark to first dark we have 4 beta and additional first dark to central beta by 2. So we have 4.5 beta equal to 8 beta dash. Now using value of beta, 4.5 d lambda naught by d is 8 d lambda naught by mu d. So d and d gets cancelled, or 4.5 lambda naught is 8 lambda naught by mu. Lambda naught gets cancelled, so mu is 8 by 4.5. So this is less than 2, but not considerably less than 2, hence it should come as 1.78. In question number 42, it says which one of the following represents forward bias diode? A forward bias diode is one in which the input side is at high voltage and output is at low voltage. Then this diode will conduct and it will be called as forward biased. That is, the P side is at higher voltage and N side is at lower voltage. So, looking at the options, the first option is correct option because 0 is more than -2. Hence, it is a forward biased diode. Now, it says Polaroids. Say Polaroid has a particular transmission axis. There are two Polaroids with their axis perpendicular. Say one has vertical axis, other has horizontal axis. A third Polaroid P3 is kept with axis at 45 degree. At axis 45 degree angle. The intensity of transmitted light through P2. Thus, now the unpolarized light is incident here. So when an unpolarized light is incident through a polarizer, the intensity crossing is I0 by 2. Now the Polaroid makes angle 45 degree. So using law of Malus, which is I is I0 cos square theta, will give you I0 cos square 45. Cos square 45 is 1 by 2. 1 by root 2 squared is 1 by 2. So it is I0 by 2. But we already have I0 by 2 here. So now it will become I0 by 4. And once again from the previous axis, here angle is 45 degree. So 45 degree, again a similar treatment. It reduces to I0 by 8. Therefore, resulting intensity is I0 by 8. In question number 43, it says, in an electromagnetic wave in free space, the root mean square value of electric field is 6 volt per meter. The peak value of magnetic field is. So, in an electromagnetic wave, E RMS by B RMS is equal to speed of light. So, B RMS will be E RMS upon C. And now, the peak value of magnetic field B naught will be root 2 times B RMS. That is the relation between RMS and peak value. So, is root 2 times E RMS, which has value 6, upon C, which has value 3 into 10 raised to power 8. So, it becomes 2 root 2. 2 root 2 has value 2.83. None of the option has this coefficient. So, B is correct option. If theta 1 and theta 2 are apparent angles of dip observed in two vertical planes at right angle to each other, then the true angle of dip is given by. So, apparent angles of dip. When the BH, the horizontal component, is taken in a particular plane other than the magnetic meridian, then it becomes BH cos, say if this angle is phi, so it becomes BH cos phi. The vertical magnetic field remains same. Angle of dip is the net angle which is formed. So in this new plane, we have tan delta dash, the apparent angle of dip, delta dash, as BV divided by BH cos phi. Whereas true angle of dip, tan delta, is BV divided by BH. In two perpendicular planes, so if in one of the planes we have component BH cos phi, then in its perpendicular plane tan delta double dash will be equal to BV by BH cos 90 minus phi, which is sin phi. That is BV by BH sin phi. We already know that in perpendicular planes, if one of the component is cos, then other will be sin. So what we see here is the cos phi and sin phi comes in denominator. Now to get rid of cos and sin, we must take reciprocal and square them, because cos square phi plus sin square phi will be equal to 1. Hence, in place of cos square phi, the proportionality will give us 1 by tan square delta dash plus 1 by tan square delta double dash, and obviously this will be equal to 1 by tan square delta. In this question, delta has been replaced. This has replaced by theta 1, this is theta 2, and this is theta. So obviously when they reach in numerator, the relation is cot square theta 1 plus cot square theta 2 is equal to cot square theta. So the correct option is first. In question number 45, the points A to B, positive charges move from A to B. So A in each case is 10 volt and B in each case is 40 volt. So what we see here, that in all the 4 cases the potential difference is of 30 volt. So in all the cases, work done, which will be equal to charge multiplied by this 30 volt difference through which the charges are moved. Hence, work done will be same in all the cases. So most appropriate answer is B, which says in all the 4 cases the work done is same. Thank you.